对对对
在那边。好
，Evelyn 你好，
你好
我是 Kevin。Hello， 各位观众大家好，我们今天请到我们香港的 Eric 连线来跟我们讲，how to extract X for receptor。那这个主题的话，就是我们 Eric 等一下要介绍我们人工智慧 OCR 这一个部分。那我们就时间差不多了，那我们就交给我们 Eric 来讲解。
好，
谢谢 Eric， 交给你了。
谢谢。不好意思，我中文不太好，所以我会用英文在说这个 talk。好，我们先开始好吗？好。Hello everybody, this is Elliot from Our Sky. And today our talk will be centered by this problem statement, how to extract X from receipts, and X being a collection of amounts, dates, and time. And back in the days, we had a few clients asking if we can extract information from some documents like receipts and pass them back the results through APIs. So we had to solve this problem, and eventually we have turned this solution into a product called FormX. So let's get started. This is just another, a more detailed version of the problem statement, so let's skip it. So the final solution of our process of solving the whole problem can be divided into 4 stages. First, we get data from received images from OCR providers like Google Vision. And then we process and transform them into horizontal lines to have a standard basic unit for us to work on and for the AIs to recognize the things. And then we can find candidates from those horizontal lines. And finally, we will pass them to the AI models. I think some of you may be wondering how have we trained our AI models? The training process is actually quite similar to these 4 stages. We have only put in one more stage in between 3 and 4. So we had like 1,000 of received images as our training data set. And then we just pass them through Google OCR and then make them into horizontal lines, find the candidates, and then we mark the horizontal lines. We mark the candidates in the horizontal lines. So the AI can know which is a positive result and which is not a positive result. Then after that, we will just pass the labeled data into the AI training process. And then we have like various trained AI models for us to do the classification. So let's dive in the first stage. The first stage is quite simple. We literally just pass images to Google Vision, and then we will get an output, which is a JSON grouped into the following hierarchy. So each entity comes with a bounding box, which is 4 pairs of XY coordinates. With that, you know which area is located at which part of the received image. And we only need the words and symbols, so we can ignore page, block, and paragraph. Here is an example of the response from Google Vision. So I've trimmed down the actual data for this image to fit in this slide, but yeah, you can get the idea from that. The bounding box is an array of 4 pairs of XY coordinates. So this one is just the top left corner of a word. So this one is literally this part. And a word contains various symbols. It's like you have a word WORD, and then there are 4 characters in there, WORD, right? So this one, the first item in the symbol array, is just the first item of the word. So say we have a word WORD, this is W. And then the vertices array, the first item is going to be the top left corner again, because the first character in the word is going to share the same top left corner as the word. So this one and this one, they are going to be the same. And the array contains 4 pairs of coordinates, right? So they goes with the order like the first one, the second one, the third one, and the fourth one. And then after we have got the plain text pieces from Google Vision, because those results from OCR services, they tend to be not labeled and they are not structured at all. So we do not know what part or what fragment of the response is or are our target data. So we have to do a lot more things. So in this part, we will group the words into horizontal lines relative to the result, sorted by vertical offset. Vertical offset means those y coordinates. So it means whether a word is at the upper side or the lower side of an receive. So yeah, that's pretty much that. And why do we do that? That's because information is always printed horizontally on a receive. And we would like to get rid of not horizontal enough words and be able to represent combinations of words and compare spacing between entities on the same line. Because like if you don't group words into one line, then you will not capture the space between them and you will not capture the combinations between the words. So we had to do that. And it's also provide us easy access to adjacent lines because like, you know, sometimes the total amount on a receive can be located just under some keywords like total amount or some lines. So we would like to have access to adjacent lines for us to make the classification result more accurate. So here is another example of an receive. So this one is intentionally tilted. It has a tilted angle. And so the relative part becomes very important here because like we would like to get relatively horizontal lines instead of just horizontal lines because like this one is like tilted. So it's relative to the receive instead of just being horizontal. So with that, we can accommodate those images with a tilted angle. So how do we convert words to relatively horizontal lines? It's actually quite simple. A factor can be computed from each word's vertices. I mean those 4 pairs of XY coordinates. So with this equation here, the direction of a word can be obtained from such a factor because like H here is just a factor. And then with this, we can calculate the average factor or the average direction of all words on one receive. So once we have got the average, we can then filter out those not so valid words. I mean, those not so horizontal enough words. So with this for loop, we put in each word in there, the factor of each word, compared to the average factor of all words. And then we calculate the distance between them. And if the distance is less than a threshold we have set, then we design this word is horizontal enough, which is considered a valid word, which we will use it, which we will group it into a horizontal line. And for those who isn't so valid, I mean those words which isn't horizontal enough, we will just throw them away because like they're not that important to our final solution because they're not the targets. So yeah, afterwards we will sort the valid words with their vertical offset, which is obtained from their bounding box, the y coordinates. And then now we have got the valid words and we have their y coordinates, right? So we can create a line out of the first word. And then we move on to the second word. And if the second word is close enough to the first line, which is created from the first word, then we will put the second word into the first line. Or if the second word isn't really that close to the first line, we would then create another line for the second word. So we can then move on to the third one and see if it's close enough to the second row and so on. So you get the idea, which sounds like a pretty good solution, right? And this is just to visualize how we get the vertical offset and horizontal offset. In case the word is tilted, we can still calculate the vertical offset and the horizontal offset because we have the XY coordinates of the 4 corners of our word. But we do have a problem. The problem is that sometimes the OCR API, they don't return like really accurate results. I mean, Google APIs, I mean, the Fission APIs can almost always recognize the words out of images. But the thing is that they have messed up vertices, which means they have not so accurate corners, or some outliers, we will say. So outliers means though outliers are those words which are not valid or not horizontal enough. So with that, our word pool is actually contaminated. So the average factor becomes quite meaningless because some of the word in there will affect the accuracy of that. So in this case, we had to ransack the outliers. And ransack is just the short form of this theorem, which is called random sample consensus. So with this theorem or this formula, assume there is like 70% of chance that we will get an inlier, a valid word, a horizontal enough word. Then if I want to be 99.999% sure that an inlier and valid word is picked, how many times should I try, or how many times should I loop through the words and filter out those outliers? 70% of chance is actually quite pessimistic, as most words are relatively horizontal on the receive. That just provides us a buffer and ensures most words are inliers. So let's look at the theorem. Here we have the formula. And if you look at it closely, you can see that all of the variables, they do have their placeholder on here. So you can just sub in the values into there and see how many loops I will need to filter out the outliers. So I want to be 99.999% accurate. So I put it here. And then the inner ratio is 70% as defined in the last slide, which is put here. And then the sample need to fit a model is just 1. That is because like each time I try to put a word into a line, or each time I try to calculate the average factor, I only take out one single word. So K is 1. And N is just the run I need to get rid of all the outliers. So I have the final N. So if you put in all the values in this equation, you will get roughly 10 iterations for N. So I will need to run ransack for like 10 times before I can be sure that all of my words are horizontal enough. All of my words are 99.999% horizontal enough. So yeah. So the problem is solved. We now have an array of horizontal lines sorted by vertical offsets. Then we can move on to candidate extraction. With the horizontal lines computed, we can now use regular expression to filter out those candidates. Because like at this part, we are yet to do the classification. We're just trying to get some candidates out from the lines so that we can feed the candidates to the AI. So here's an example regular expression for price, which is total amounts. And we usually use 2 outputs from each regular expression because like with and without space can be a lot different for one candidate. As you can see here, this one is quite a massive value. But if you add a space in between here, you can see that we now have a valid time and a valid date. So by putting a space in there and not putting a space in there, that gives us as many combinations as possible, so we don't miss out on the actual targets. And here comes the AI classification models. We have employed a bag-of-words model to help us to filter out those some not so valid candidates first. So we build a dictionary from all words from the training data set, from that around 1,000 something of receives. So we build a dictionary. and then we check if the incoming target or the incoming candidates have the surrounding text pieces like DAG. So if we have a BOW like A, B, C, D, E, and F, but we don't have a G character in there, then if a candidate passing has DAG, it will be considered as a not valid candidate because we have never seen a word like G before, a character like G before, so this will be ignored. And the range of surrounding text pieces varies across targets. So for price or the total amount, we only look at the same line. But for time and date, we look at +1 and -1 lines. That is because most of the time for dates and time, they usually have the placeholder dates or time. Or in Chinese, 日词跟时间, like up a line or like down the line. So we would like to take in that part as well. So here comes the amount classifier. We have 3 different AI models trained just for the 3 targets we would like to obtain from receives. So for total amount or price, we have used the model logistic regression. And some notable features are the position in receive. So it's like normally a price doesn't really show up at the top of a receive. So we will take that into account so that the AI model is trained that way to provide us like more accurate results. And also we will look at the candidates, whether they have a symbol of $, a dots, or just a comma, because they are reliable indicators on whether a candidate is a valid target or not. And then we will also have some range checking features. So, I mean, receipts from a supermarket often don't have a sky-high amount. So it's like when you go to Family Mart and you get like a bottle of tea, it will not like exceed the amounts of like 100, right? So we have set that to just to get the result to become more accurate. And this is adjustable by receive type, because like when you go to like a really expensive, a luxury store, then the range will become like sky high maybe. So we make this one adjustable. And here comes the date classifier. We have used random forest for this one. And again, position in receive is very important because like a date is usually located at the top or bottom of a receive. And it most of the time has symbols, because for a date you have like a colon, and a slash with less than 2 occurrence. Because like when you see a candidate with like more than 2 slashes or like more than 2 colons, it's most likely not a candidate, because like you only have like hour, minutes, and seconds. So you only have like 2 occurrences in there. And we also see if the full year is shown in one candidate or not. And we also check if a month is presented in English. And we also check if time candidate is on the same line or if it's on the +1 or -1 line. We also check if there's a difference separated between the values of hours, minutes, and seconds. So this one looks a lot more convincing as a valid date than this one, right? And lastly, we have the time classifier, which is again used the random forest model. And again, we check the position and receive, and we check the symbols like the date candidates. And we also check if AM, PM is in the pattern, and if the dates and date candidate is on the same line or on the + or -1 line, because the date and time, they usually show up pretty nearby to each other. So yeah. And during our development of our AI model training, especially, we had to handle some unbalanced data set, because like in our case, we had much more negative samples than positive samples. Because like in one receive, so we only need 3 targets, but there are like a lot of other words and other sentences in a receive. So by directly passing the training data to the models, we yield some super biased models towards false. So we would like to avoid that. And a simple fix, which is not very pretty, in fact, is to replicate the positive samples so the ratio becomes 1-to-1. And these are our future tasks. We would like to expand our training samples. We are in fact trying to get some receives from Taiwan so that we can also accurately extract the amount, state, and time, the ID. I think there is an ID on Taiwan receives, so we would like to do that as well. And we will also look into transforming data in new ways and play with new input parameters and some more AI models, because like there can be more accurate models or more accurate approaches to solve this problem. So we will be looking into that. And now it's a time for a live demo. I cannot guarantee the live demo isn't going to go wrong because like it's a live demo. So let's see. So this thing here is our Formx portal. And the receive one is solved. So we have made it a template on our portal. And here we have a list of receives, Hong Kong receives. So like users can just go into a template and try them out. So let's see. Cool. Right, so here we have the total amount extracted, the dates and time. So we can just cross-check it with the image up here. So you can see the total amount is here. The date says, I can't find the date. All right, the date is here. So as I mentioned, March, our English month name is a feature that is usually going to be marked up because it is more likely to be a valid candidate, to be a valid target, in fact. So this one is extracted here and the time is here. So we have normalized the time to 22, 30, and 00 because the second information isn't provided. So let's have a look at the other one. Let's take a look at this KFC one. Right, so we have the total amount 404 with the date, the 3rd of February in 2019. Let me find that. Yeah, here you go. And we have the time, 12:32, which is located right here. So yeah, this is the live demo done. Right, let's get back to slides. And yeah, if you're interested in our solution, you can go to formextractor.oscar.com or formx.oscar.com. We have recently changed our name to Formx, but yeah, both links will work. And here's an article related to this talk. So if you find any parts of this talk unclear or confusing, you can either ask me or look at this article, or you can ask me afterwards, because like I will be reachable on any of these channels. So this is my Twitter account, and this is my LinkedIn account, and this is my email. So if you have any problem, just let me know. And now comes the Q&A session. So questions are welcome in both Chinese and English, because I can understand Chinese. I just can't really speak it fluently. So yeah.
Oh, OK。我们看一下 YouTube 有什么样的问题？有问题哦，看一下，看一下。OK。
How can other developers use or integrate Formx if they already have existing? Oh, 我用英文答吧，因为他用英文问。
可以啊 ，OK 啊。
So in this part, oh, it sounds very salesy, but let's go back to the portal and look at this part. We have APIs. So this here is a HTTP endpoint, so that you can just point to this endpoint, and you can put in your form ID and your image, so that you can get the extraction result, which can be integrated to any applications or software, as long as you have API calling abilities. 对。还有其他问题吗
？Elton，那你要是用中文再讲解一次？
中文有一点难，但是我详细一下。我可以用 API 解释字吗？因为我不知 API。
可以 ，API 可以讲，没问题。
好，所以这个线上这个 John 呢问我怎么能从不同的 APP 跟原体去拿到 Form X 的 extraction 结果然后呢，其实我们有 API 所以只要你 call 我们的 API， 就是这个 worker.formextractor.ai.com/extract， 然后你把你的 Form ID 跟你的 image URL 还是你的 image binary 我们就 accept image binary image path image URL 透过一个 request body 还是 form data 都行你就能把你的image 传给我们的后台，然后我们的后台就会透过 API 传回一些 JSON 给你，所以你的 APP 或者你的原体能直接用那些 extract 出来的结果。对，说的还好，不好意思。
OK， 蛮清楚。那我们要如何申请这个 app？ 就这个 ID， 就这个服务 API， 我们要如何跟你们申请这个 API？ 这个 API
其实很简单的，我们有这个fun page， 然后你直接从这里 sign up 了。我们有，不好意思，我先开一个无痕模式，然后呢，你就能 sign up 了。然后 sign up 之后，我们有一个100个 free quota， 你能去 extract 你要的东西，你就能试用一下Form X 的不同的 features
了解。
对。
好，就是1个礼拜的试用期，是。
不好意思，听不到
一个星期的试用期 ，1 week。
不是，我们有100个 free 的 API call， 然后你用掉你100个的免费的 call 之后就要给钱但是没有时间限制的，只要你不用完你100个 API call 就行。
100个 query 就对了。
对，然后其实你要 sponsor 的话，也能直接找我们能谈一谈，看看能不能给你一个 sponsor。对，就是一个 record。对，我们也有这样的 plan。对，好。
那我们线上还有什么问题？没有了。对，
放弃。
感谢，对。
我先原请我的 slide 好吗？其实我还有一张。
好。
我先感觉一下我们是什么东西来的。So let me switch back to English. And Our Sky is a Hong Kong-based company. It's actually also Taipei-based right now. We also have a Taipei office. So this photo here is a snapshot of our Taipei office with our lovely developers and designers working closely. So we have like 50 plus passionate developers, UI, UX, and PMs, and we have 12 years of agile development experience. And we had 2 best apps of the year from Apple App Store, and we have 2 offices, like I've just said, and we have 6 cats. So these 4 cats are in Hong Kong, and this one unfortunately has passed away earlier this year. And these two are in our Taipei office. So it is pretty much a company culture for us. So when we have an office, we should have some cats in there. So that's pretty much it. So thank you very much, GTG Taiwan, for having me today, and thank you for everyone for coming. 谢谢，
谢谢，谢谢，
我们下次再见。See you next time. 好，
拜。
感谢啦，拜拜。